Vector Express, where we deliver not just packages but also knowledge.
And today's special delivery, vector quantities. Because without direction, our deliveries and our physics problems would be lost.
Right. Imagine I only know the distance, not the direction. I'd end up at the wrong house every time.
Exactly. So in this video, we'll explain what vector quantities are, how they differ from scalars, and how they guide our every move in delivery and in science.
Okay, Krista, tell us what these vectors really are.
Sure, a vector quantity has two parts, magnitude, which means how much, and direction, which means which way.
So, if I'm driving 5 kilometers east to deliver an order, that's a vector. 5 kilometers is the magnitude and east is the direction.
But if you just said 5 kilometers, that's only a scalar quantity. It tells you how far, but not where.
So scalars are like saying I traveled 5 kilometers, while vectors are like saying I traveled 5 kilometers east. Both matter, but only one tells the full story.
Let's sort our deliveries. Which ones are vectors and which are scalars?
Okay, here are the vectors orders. Displacement, velocity, acceleration, force, and momentum.
In the scalar orders, distance, speed, time, mass, and temperature.
Good job, team! Notice, velocity and speed look similar, but velocity has direction, while speed doesn't.
Same with displacement versus distance. Distance tells us how far the package traveled, while displacement tells us where it ended up from the starting point.
Here's how we represent vectors with arrows. The arrow's length shows the magnitude, and the arrowhead shows the direction.
For example, if our delivery rider applies a force of 10 Newton north, we draw an arrow 10 units long pointing up.
And in math, we write vectors as bold letters, like F or F with arrows on top.
We can even use coordinates like 3, 4. That means the movement is 3 blocks east and 4 blocks north. Simple.
When we look at vectors on a map or in a diagram, we're actually seeing a story of movement. Every arrow begins at a starting point and ends at a destination. Just like how a rider starts at the hub and travels to the customer. That arrow can tilt up, down, left, or right, depending on the direction. And the longer the arrow, the farther or stronger the movement. So every little arrow is like a mini delivery route showing what's happening in the real world. Now let's combine two deliveries, or in physics, two vectors.
If Carlos goes 5 km east and then 5 km north, the total path isn't 10 km in one straight line. The resultant vector is diagonal.
Yup, like this. find that diagonal, we use the Pythagorean theorem. R is equal to square root of 5 raised to 2 plus 5 raised to 2 is equal to 7.07 kilometers. So the resultant vector is about 7.07 kilometer northeast. So the
That's like combining two routes into one faster, shorter path. Super efficient.
We can also subtract vectors, like taking a shorter route back, or multiply them by scalars to change the speed or intensity without changing direction.
vectors operation help us combine different movements into one final direction, which is super useful in traveling, engineering, and even gaming. For riders like us, this means less time on the road and a quicker delivery. In math class, it may look like arrows and formulas, but in real life, it means discovering the best and most efficient way to reach a customer, a destination, or a goal. Even subtracting vectors is like correcting a wrong turn to get back on track.
Vectors are not just for riders. They are used everywhere.
Pilots use them to navigate airplanes against wind direction.
Engineers use vectors to design bridges and buildings so that all forces stay balanced.
Even when we play sports, like shooting a basketball, our throw's velocity decides where it lands.
Everywhere we look, vectors are quietly working behind the scenes. Whenever something moves, changes direction, or is pushed or pulled, that is vectors in action. Even apps like Google Maps and Waze use vectors to show the correct path and how far we still need to go. So the next time you walk, throw something, or even scroll through a map, always remember, vectors are guiding your journey step by step.
So, to wrap up our delivery,
Vectors have magnitude and directions.
and that's how better quantities helps us stay on the right path, both in physics and in life.
So, just like our deliveries, life also needs direction and purpose. Magnitude tells how strong our effort is, but direction tells us where that effort should go. And when both are combined, we can accomplish any mission efficiently. So, keep aiming forward, choose the right direction, and let your goals be your vectors. With Vector Express spirit, every move leads to success.